Forever chemical levels surge as ozone-friendly refrigerants increase pollution, the amount of trifluoroacetic acid, TFA, a potentially harmful, forever chemical, has tripled globally in the past 2 decades due to the widespread adoption of refrigerants designed to protect the ozone layer. While these replacements were intended to address one environmental crisis, they're creating another. TFA accumulates in the environment for decades or centuries, with long-term effects on human and ecosystem health remaining largely unknown. The unexpected consequences of ozone recovery in 1989, the world banned chlorofluorocarbons, CFCs, chemicals found in refrigerators, aerosols, and other products after discovering they were depleting the ozone layer. These were replaced by hydrofluorocarbons, HFCs, which, while safer for the ozone, break down into TFA in the atmosphere. Now, even these HFCs are being phased out in favor of hydrofluorolefins, HFOs. However, HFOs decompose at a much faster rate into TFA, with HFO 1234 if generating 10 times more TFA than the HFCs they replace. This isn't a future concern. Atmospheric measurements show TFA deposition has risen from 6,800 tons annually in 2000 to 21,800 tons in 2022, and this trend is expected to accelerate. The chemical has already been detected in high concentrations in the blood of 90% of people in China, linked to industrial pollution and wet climates. Toxicity and environmental persistence, TFA's exact health impacts remain unclear, but studies show it can cause developmental deformities, such as eye defects in rabbit fetuses. The European Union classifies it as harmful to aquatic life and is considering whether it also poses reproductive risks to humans. Once released, TFA doesn't disappear. It accumulates in soil, surface water, and eventually sediments at the bottom of the ocean. The search for alternatives to the situation calls for a reevaluation of refrigerant choices. While phasing out CFCs and HFCs is essential, blindly adopting replacements without full understanding is counterproductive. Natural refrigerants like ammonia and carbon dioxide offer viable alternatives. Ammonia already cools industrial processes and warehouses, while CO2 has a low environmental impact. A call for immediate action, the increase in TFA levels isn't irreversible. If emissions of HFOs are halted, TFA production could slow dramatically due to their rapid breakdown in the atmosphere. However, the cycle of unintended consequences must be broken by rigorous research into alternatives and transparent regulation. The EU's own efforts to ban forever chemicals have been undermined by hiring consultants with ties to chemical manufacturers, highlighting the need for independent scientific assessment. We need to take a serious look at whether there are better alternatives to HFO 1234 if TFA has increased and is going to further increase. It's been found in all kinds of food products now that it never used to be found in. It's everywhere. Lucy Carpenter, University of York. The surge in TFA demonstrates a crucial lesson. Environmental solutions must consider the full life cycle of chemicals, not just their immediate benefits. Ignoring potential long-term consequences risks exchanging one crisis for another.